Hello, I am Harry, and today I am introducing the concept of phase change. On Earth, materials exist in one of three main states of matter: solid, liquid, or gas. Materials can change between all these states, and when such a change happens, it is called a phase change. It is important to understand that when a state change occurs, a substance's properties will also change simultaneously. I believe that all of you, even just from everyday life observing, it is very easy to see how solid, liquid, and gas are quite different. More specifically, I will use a glass of ice water as an example, where in a glass of ice water, the water it itself is a representation of the liquid phase. The ice inside there is a representation of its solid phase, and the water bubbles coming up are representing the gaseous phase. So first, let's start with solid. Solid, they have a definite volume and fixed shape, where the molecules inside vibrate around their arranged position. And on the other hand, liquids, they have a definite volume, but they are conformed to the shape of the container that holds them. Using different kinds of cups, we can see that the waters we put in there are in different shapes. And liquid molecules may move around as well as vibrate, which is different compared to solid. The third state of matter is gas, where it has no definite shape and it also fills the volume of their containers, where not only for water vapor, a balloon might be a more visualized example, where it is very easy to squeeze the balloon and make the gas inside into different shapes. In the state of matter of gas, the molecules move in random directions and they experience almost no intermolecular forces. And then I want to say that if the state change is reversed, the substance will recover the properties it had to begin with, which is very important to remember. So now we know that matter can transit between those three states, and it is becoming the question that how does it happen? Now imagine in winter that water is very easy to become ice, and how when you are taking shower, water is very easy to become water vapor. It is quite obvious that matter can transit between the three states when heated or cooled. But why is heat key in all this? When a material is heated, it actually absorbs heat energy, and such additional energy can help cause attractive forces between molecules to break, which leads to rearrangements of particles because the attractive forces no longer hold them together as tightly, which explains what I earlier talked about, how solid has a stronger intermolecular forces and liquids has less, and gaseous substances almost have no intermolecular forces. This is a representation when the attractive forces between molecules are breaking. And such thing would happen not when a liquid is becoming, and such bond will break not when a liquid is becoming a gas, but also when a solid is becoming a liquid. You probably now understand that phase change is the transition between solid, liquid, gas, those three states of matter. But what are the specific names of those transitions? Now it's time to learn some vocabulary. First, evaporation and boiling happens both when a substance transforms from a liquid to a gas. But evaporation here is a slower process than boiling, even though it achieves the same state change, where the differences between those two is talked about in another video made by Jack Lee. And both of those two kinds of state changes are together known as vaporization, where vaporization is when a state of matter transforms from a liquid to a gas. And then, the opposite of the vaporization process is the process of condensation, which is the transition from gas to liquid, where the water bubbles out of a cold can of soda on a hot day, the water droplets, the dew on the grass in the morning, or even the steam of mirror after a hot bath are all great examples of condensation that are very close to us in our real life. This is when water vapor in the air has cooled down to form liquid. And now let's think about the transition between solids and liquids, where it is melting and freezing, which you probably know already. Where melting is when a solid is melting into a liquid, and freezing is when a liquid is becoming a solid. And now we come to a very special and very rare case, where solid and gas can actually be directly transformed into each other, where when solids are directly turned into gas, the process is called sublimation, which happens very rarely, where the most common example is probably solid carbon dioxide, or in another name, dry ice, where when subjected to a certain pressure, it will turn directly into gaseous carbon dioxide. And then there is of course an opposition to sublimation, which is called deposition, which is when a gaseous substance directly turns into its solid form. Diagrams and models are important parts when learning physics. Of course, when coming to phase change, there are certainly some diagrams that will help you better understand them. So I will present two diagrams. where one is actually the reverse of the other one. So let's look at the first one. It is apparent that the x-axis is time and the y-axis is temperature, and it shows quite clearly how temperature is changing as time goes, where the concept of phase change is explicitly presented here. On the first part of the curve, where the red line is going down, it is when the gas is cooling, and then we can see there is a sharp turn, and then the curve becomes a straight flat line. This is when gas is condensing. Even though heat energy is still provided to the substance, such energy is actually used for it to change its phase, where the amount of energy involved here is actually the specific latent heat, which probably will be talked about more in other videos. So here we can see that as gas condenses, there's actually this time where the temperature stays the same. And then after this period, of course, the gas is turned into liquid, and then the liquid is cooling, and then it freezes, and now we count that freeze is when a liquid is turned into a solid. So then afterwards, the liquid is turned into a solid. This is a graph representing when a substance starting from a gas is experiencing the process of cooling, how its temperature is changing, and how it is turned from gas to liquid, then finally to solid. And here is the opposite of the graph, where it is actually quite similar, despite the fact that it's going from left down to right up. So this time we are heating this substance, and it is starting from the solid. The first going up curve is when the solid is heating up, getting its temperature higher and higher, and then at the sharp turn it is starting to melt. And when melting, the temperature is at a constant level, and it is changing its phase into liquid. And then again, liquid is starting to heat up, and then it's the process of liquid evaporating into gas. And then now it's this constant temperature part again, and where at the end, it turned into gas and then continued to heat up. So what those two graphs actually want to tell us is that in the process of phase change, the temperature of such substance actually does not change. At zero, for example, at 0 degree, there might be ice, there might be water, but if you put 0 degree ice and 0 degree water together, it will be a 0 degree mixture of ice and water, because at such turning point, both liquid and solid can exist together, and this is how the diagram represented with this flat line.